Good morning, everyone. Today, I am going to use several examples to teach you a systematic method to write down Lewis structures. The first example we're going to go over today is nitrate ion. Nitrate ion has -1 charge. Generally, if you are asked to write down the Lewis structure, you have to be told the connections between all atoms. Generally, this will be given in the form what we call a skeleton structure. This is a skeleton structure for nitrate ion. I want to emphasize, in the skeleton structure, the line does not mean a single bond. Let me emphasize again. In the skeleton structure, a line does not mean a single bond. Whenever you are given a skeleton structure, the next step is put down the correct number of valence electrons around each atom. Let's start with nitrogen. Nitrogen is a group 5 element. It should always have 5 valence electrons. And for this nitrogen, in the skeleton structure, it has 3 neighbors. And we put down 1 electron between nitrogen and every neighbor. And then you put down the 2 additional electrons on the other side. And then for this oxygen is a group 6 element. It has 6 valence electrons. And because this oxygen has only 1 neighbor, we put down an electron from oxygen between oxygen and its neighbor, and put on the other 5 on the other sides. And then we do the same thing for these oxygen atoms. We put on 1 between oxygen and its neighbor. We put on 5 on the other sides. And then for this oxygen, we do the same thing. As you can see that I use different symbols to represent the electron from for each atom. This way, I can make the calculation of formal charge very, very easy. And then remember one thing. Nitrate ion has -1 charge, which means it has 1 additional electron. As a general rule, we put down the additional electron on the most electron active atom in the structure. In this case, oxygen will be the 1, but we have 3 oxygens, 3 oxygen atoms in this structure. So you may ask me, which one we should put? And my answer is, it does not matter. So you just pick the one you like the most. In this particular scenario, I want to put down additional electron next to this one. Whenever you put down additional electron, you put a -1 formal charge next to it. I suggest you to do this immediately. You may forget at the end if you don't do this. And then you start to count how many electrons are around each atom. In this case, 1, 2, 3, 4, 5, 6, 7, and 8. You have 8 electrons around this oxygen atom. And then you have 1, 2, 3, 4, 5, 6, and 7 electrons around this oxygen atom. And then you do the same thing. You have 7 electrons around this oxygen atom, and then you have 9 electrons around, I made a mistake. We only have 8 electrons around this nitrogen atom. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, we only have 8 electrons around the nitrogen atom. And then, after this step, we find that we have 2 atoms has less than 8 electrons. So in this case, this is not a legal Lewis structure. We have to make sure every atom has 8 electrons around that. To make this happen, we have 2 ways to do. One we call share, the other one we call borrow. When we say share, we mean this. So 1 electron from oxygen put here between oxygen and nitrogen, and 1 electron here originally from nitrogen and now is shared between nitrogen and oxygen, which will possible to make another bond. So this will turn into 8 electrons and this will turn into 9 electrons. And then we have to make sure every atom has 8 electrons. And as I said, if you have 7 electrons, if you want to make 8 electrons, you have to 2 ways to make this happen. One is to share, just like what we did. Or the other way is to borrow. So generally, you want share first. If share does not work, you have to borrow. So let's try share first. As we already know, share means each atom contributes 1 electron to form another bond. And then we start to count. This will have 8 and this will have 10. But then oxygen does not have any problem because it meets the octet rule. But nitrogen does have a problem because, as we can see, nitrogen is the second period element. So it can only have 8 electrons in the valence shell. So then we have 10 electrons right now, so which means it does not work. So we have to change the method. So as I said, this means share does not work. Then we have to roll back all the steps we just did. And then let's try if borrow works. Borrow means this has 7, which will borrow 1 from here. So you can say that the electron moves from one atom to another without forming a bond. So in this case, and because this one borrowed 1, you put a -1 formal charge, you put a +1 formal charge here. And then let's count how many total electrons around each atom. So this would become 8, and this will become 8. So in this Lewis structure, we have all the atoms, they all have 8 electrons, which they all meet the octet rule. So which means this is the legal structure. But as we take a look at this, this is pretty messy. In exam, I want a cleaner version. So let's get a cleaner version of this one. We put all the atoms in the right location, and then this is a single bond, this is a single bond, and this is a double bond, and we have 6 additional electrons here, and you have a -1 formal charge. You have 4 electrons here without formal charge. You have 6 electrons here, and then with a formal charge, and this does not have any additional electron, but it has +1 formal charge. So this will be the cleaner version of the Lewis structure for nitrate ion. Let's erase the messy word. And then after we get the first Lewis structure for this one, we have to always check, do you have any double bond or triple bond? If you do, you will try, say, if you get any resonance structures. So if you are given, or if you get the first Lewis structure, to find the resonance structure will be relatively easy. So here is what we do. So you put down all the atoms into in the exactly the same location, and then you move the bonds around first. So this is single, this is single, this is double. So when you move the bonds around, you can change this one to double and this one to single. The total number of bonds still remain the same. So it will become this. And then the next step, what you're going to do is you add additional electrons and make sure every atom get the octet. So this one needs 4 more electrons. This one needs 6 more electrons. And this one needs 6 more electrons. And then the next step is we are going to calculate formal charge for every atom in the structure. So let's start from this atom. So the equation to calculate the formal charge is the formal charge equal to number of valence electrons minus the number of electrons assigned. So for this oxygen atom, it always has 6 valence electrons. And then for the number of electrons assigned, you will say whether it's a lone pair or shared pair. If it's a lone pair, all the electrons are assigned to this atom. For this one, it will be 4. And then if you have a shared pair, the total number of electrons divided by 2, because each bond represents 2 electrons. If it's divided by 2, it will be each line represents 1 electron assigned to this one. So this will be 2 electrons assigned to this one. And this will be 0. So this oxygen does not have any formal charge. So as required, we have to calculate the formal charge for every atom in the structure. So the next one, what we are going to do is we're going to calculate for nitrogen. Nitrogen is a group 5 element. It has 5 valence electrons, and then minus the electrons assigned. Nitrogen does not have any lone pairs. It only has shared pairs. 1, 2, 3, 4. This will be plus 1. So the formal charge for this nitrogen, it will be plus 1. And then we should calculate for the other atoms as well. So for this one, the valence electron for oxygen will be 6, and the number of electrons assigned will be 1, 2, 3, 4, 5, 6. 6 from the lone pair, and then 1 from the shared pair. And then this will be -1. So the formal charge for this one will be -1. And then we have the last one we're going to calculate is this one. We do the same calculation. The number of valence electrons is 6, and the number of electrons assigned is 6 from lone pair, and then 1 from the shared pair. So remember, each shared pair has 2 electrons, but only half assigned to this one. So it will be -1. So this will be -1 formal charge. So now this will be another legal Lewis structure. And then we are going to write down the third resonance Lewis structure for nitrate ion. I'm not going to show all the detailed steps because it's all the same as what we did for this one. I just give you the final answer for this one. And then after you finish all the resonance structures, I want you to put down the arrows, double arrows, to connect all of them. And this will be the final answer for the resonance structure for nitrate ion.